Hello everyone. So let's talk about biomagnification and bioaccumulation. Toxic substance, when it's released into the environment, it may degrade quickly and become harmless, or it can remain there forever, or for a long time, years or decades. So at the rate at which given substance degrades depends on its chemistry and the factors like temperature, moisture, and sun exposure. So as the substance affects the species, if it's in the environment, its population may become smaller and in turn affect others in the food web. And then it can have a cascade effect through the entire ecosystem. Just to show you an example, so if this species was affected with these chemicals or the substances and the population didn't exist any longer, then there'd be no predator for these. And then they'll probably overgraze or um, take down all the plant species. So kind of goes back to the keystone species. And so I already said at the rate which substance degrades depends on the chemistry and other factors. So there are some chemicals that are in plastics that can stay there for a long, long time and resist degradation. And many toxins, they degrade into simpler compounds called breakdown products, which may be less than or equally as harmful as the original substances. So, for example, DDT breaks down into DDE, and that's highly persistent toxic compound in its own. So it might be as harmful or maybe a little bit less. All right, so within an organism's body, some toxic substances they're quickly excreted and some are degraded into harmless breakdown products. But like we said before, some that are not metabolized, those are going to stay in the fat cells. If they're fat soluble or oil soluble, those are absorbed and stay in the body tissues. And if given enough time and exposure, bioaccumulation will happen. So here, over time, it's going to add more and more of those substances into, let's say, into the fat cells of this fish. And over time, this is what's going to happen. This bioaccumulation, just kind of collecting it over time into the tissues of the body. So these will bioaccumulate and be transferred to other organisms as predators consume prey. So that will be biomagnification. So let's say this fish is right here and it's get eaten by these seals, then they're probably gonna eat more than one of these fish, as their food supply, and then they're gonna have more of those amounts. The same thing with this killer whale. So as predators ingest more and more prey over time, biomagnification happens, like I said, resulting in a greater concentrations of the toxin. Biomagnification of DDT caused many North American birds of prey to decline from 1950 to 70s due to thinning of their eggshells. So here, it's water, the zooplankton, small fish eats the zooplankton, large fish eats the small fish, and then bigger birds or fish eat the large fish. And this is the amount of DDT. That's how much it was present in the water. Zooplankton ended up with this much, and then it just started increasing as more of those prey got eaten up by the predators. Here's another picture. The farmer sprays the pesticide on the crops. Rat eats the crops, and the pesticide builds up inside the body. The snake eats many rats, not one, many, and from each rat builds up inside the snake's body. Eagle eats many snakes, and the pesticide from each snake will build up inside eagle. That's biomagnification. All right, so toxicants, they can obviously alter the manner in which organisms interact with ecosystem services. Pesticide exposure is a factor in the recent decline of honeybee populations, affecting the ecosystem service of pollination they provide. And um, nutrient cycling is one of the many services that are present in a healthy functioning ecosystem. And decomposers and detritivores in the soil break down organic matter and replenish soil with nutrients for plant use. So when the soils are exposed to pesticides or fungicides or nutrient cycling rate is altered or changed, that can make nutrients less available to the producers. affecting the growth and causing impact that cascades through the food chains and the ecosystem.